Greetings from the BSC Designer team. In this tutorial, we'll discuss optimization functions for indicators. What is an optimization function, and how does it help calculate the performance of an indicator? Any indicator in BSC Designer has reference points: baseline, the starting state; value, the current state; and target, the desired state. We make the assumption that in the starting state, when the current value is equal to the baseline, the progress is 0%. When the desired state is achieved and the current value is equal to the target, the progress will be 100%. What happens with progress when the current value is somewhere between the baseline and target? To answer this question, the software uses an optimization function defined by the user. Let's review some use cases for the optimization function, starting with linear optimization. In this example, we have the number of qualified leads indicator. The question is, what number do we consider as good level of leads? In this case, the number of leads is measured on a scale from 0 to 20. And on the Performance tab, its optimization function is configured as maximize value linearly. The progress of this indicator will increase linearly with an increase in its current value, achieving 100% when we hit the target of 20 leads. On the gauge chart, I can see the stoplight colors used to visualize the optimization function. The stoplight changes gradually from the red zone to the green zone. The stoplight that corresponds to the current progress of the indicator is displayed in the progress column. The response time indicator is an example of another logic. It's an inverse indicator, where low value results in high performance. Its optimization function is configured as minimize value linearly. In this case, the baseline is set to 48 hours and the target is 2 hours. When we decrease the current value of the indicator, its progress will increase linearly, reaching 100% when we achieve the target of 2 hours. What if we respond even faster than 2 hours, for example, within 1 hour? The progress of the indicator will surpass the 100% and be calculated as 102%. In some cases, the context of measurement implies specific thresholds, indicating state levels that correspond to certain performance. Consider the incident response time indicator. Let's explore how its thresholds are configured. There are 3 thresholds. All responses faster than 2 hours are considered as 100% performance. Any response within the interval between 2 and 5 hours is considered as 40% performance. And responses slower than 5 hours are considered 0% performance. For now, we have been working with a measurement scale from baseline to target. However, there are certain types of indicators where we need 2 measurement scales, one from the baseline to the target to describe improvement plans, and another from minimum to maximum to cover the entire range of possible values. To activate an additional scale, I need to disable the simple input mode. What kind of indicators require such a measurement approach? Let's use the resource utilization indicator as an example. Consider space utilization in a warehouse or the average CPU utilization on a cloud server. A low utilization rate indicates ineffective use of the resource, while a high utilization rate shows usage of the resource at its limit. To communicate this to the software, let's combine the idea of linear optimization functions with the concept of the thresholds. Let's check the optimization dialog to see how the indicator is configured. On the interval of values lower than the target, linear maximization is used, and on the interval of values higher than the target, linear minimization is used. As observed on the gauge chart, to be in the green zone, we need to keep our current value around the target. Declining from the target in either direction will result in a decrease in performance. We are not limited to linear functions only. Here are 2 examples that use exponential functions to calculate performance. One is a fast saturation function, where reaching the green zone is relatively easy. For instance, consider scoring the quality of taxi service. By providing the basic required service, you can achieve an acceptable level quickly. Another example is an indicator with a slow saturation function, where reaching the green zone is challenging. This function might be employed to quantify indicators with low tolerance for poor results, such as the number of incidents of certain types. Modifying the parameters of the function allows us to adjust acceptable levels, either increasing or reducing green zones accordingly. The final example is typical for strictly regulated industries, like aviation. Let's use the percentage of trained employees to explain it. We could use a linear function to calculate this indicator. The 95% of employees trained would result in 95% performance, but it doesn't align with the business context. You wouldn't want to board a flight where 95% of personnel have passed security training. Only when 100% of employees are trained is it considered an acceptable level, which generates 100% performance. Otherwise, the personnel is not considered trained in full. To implement this case in the software, we use the current value field to track the percentage of employees trained. For the optimization function, we employ a binary maximization. In this context, binary means that the performance of the indicator can have two states only, 0% or 100%. It will be 0% even if 95% of personnel are trained. The 100% performance will only be achieved when 100% of the employees are trained. As you can see, BSC Designer provides some predefined optimization formulas, and it also allows creating your own formulas. Once you find the right recipe for the optimization formulas for your indicators, you can scale it across your organization. To do this, save the optimization formula as a template. It will be available for your colleagues in the optimization list. We discussed the most popular optimization functions and their practical application. Now, instead of dealing with dollars, hours, and the number of incidents, we deal with percentages. By defining calculation standards, we normalized indicators and made them comparable to each other. Once indicators are normalized, we can combine indicators from different scorecards, assign weights to them, or build indexes. The software will do all the calculations. As always, if you need any personalized assistance in setting up KPIs, feel free to contact the BSC Designer team.